Okay, so here is the second part of acids, bases, and pHs. You should have already watched the first part, and this is really if you want to learn a little bit more about acids, bases, and pH, so that you would be ready for the content you might see in AP Biology or AP Chemistry about acids and bases. So let's go back to these diagrams. You should have seen these before, and remembering that this basic thing here about when you add OH minus hydroxide ion to water, it actually then interacts with the H pluses, the hydrogen ions that are already in the waters. Okay, and so one important thing to remember at all times, there's always water, and water can kind of participate in the reactions a little bit as you go on. So let's think a little bit more about acids and bases. Acids usually are really easy to find out, to look at it. So here are some examples of acids. Think about what makes them acids. How can you tell they're acids? Okay? And a lot of bases are also really easy to spot. What makes these bases? How do you know? If it didn't say here, and it doesn't say acid, acids are nice to say acid in the name, bases don't, but can you tell? So the key thing, acids give away an H plus. Pretty easy. You see an extra H, usually maybe at the end. See how this H there is at the end? There's other H's in there, but there's an H at the end. Okay. And bases, many of them give away OH minus. That makes a base really easy to spot. But the thing is that not all bases do that. So a really classic example is this thing, ammonia. And if you look at ammonia, where's the OH? There's no hydroxide. How can it give that away? How can it be a base? So it really goes back to what's happening and what's involved with water. So there's really two definitions of acids and bases, and the first was made by this guy named Arrhenius. So he said, when you put an acid in water, it produces H plus ions. And a base produces hydroxide ions when you put it in water. And that's kind of our basic definition. But it's not quite as easy to see or understand as the next definition when you get to more complicated cases. It works really well for simple cases. But these guys, Bronsted and Lowry, independently came up with a different definition. They said, if there's a reaction where there's an acid and the base, the acids give away a proton. Scary, a proton? Oh, but all it is an H plus ion. Because hydrogen has one proton and one electron, and if it's a positive hydrogen ion, it means all it has is one proton. There's no electron. So perfect, a hydrogen ion. And a base accepts a proton. So basically their definition for acid is the same, but for base, it's saying it's not talking about producing an OH minus ion, a hydroxide ion. It's talking about it can take an H plus ion. And if water is involved in the reaction, if you're taking a base and adding it to water, water is going to be the acid or the base. So let's look at some examples. Here we've got a base, ammonia. We've got an acid. You guys have already seen this. And so the base will accept a proton. Here it's got one extra proton. The acid gives away a proton. Here it's got one less proton. Okay, similar. Base will accept a proton. Kind of interesting. Over here. Okay, keep that in mind. Okay, and this will give away the proton. There's one less proton. This thing has one more proton over here. Now here's one with water, an acid with water. So the acid gives away the proton, and the base accepts the proton. So one less proton, one more proton. And here's the example of a base with water. So the base will accept the proton. The acid will give away the proton. Ah, look, you've got OH minus produced, which was kind of back to the original definition. Okay, so let's look and think, when you take an acid, and an acid gives away a proton, if you go back to this, the acid gave away the proton, and we called it a base. And so it's the conjugate base. Conjugate just means kind of related, but the partner to it. And so here we've got an acid and its conjugate base. So the thing to look is acids, they have an extra OH, an extra H+, and their conjugate bases have one less H+. Bases are ready to take an H+. So if we're looking for their conjugate acid, it would have an extra H. So fill this in, pause it, fill it in, check your answers. Okay, the last thing is to remember that these are reversible reactions, most of them. So if you've got an acid and a base, here's its conjugate base, the acid, doesn't have one of the protons anymore, is a conjugate acid, the base, that got a proton added. We could write this backwards. It's a reversible reaction. So this is reactants going to products, but we could write it the other way around, and it's the same reaction, okay? So I just reversed it, and now I labeled these. Okay, here's the base, because the base is the thing that's going to accept the proton. And here's the acid, the thing that's going to give away the proton. And now the conjugate acid accepted it, conjugate base. Okay, so always just label the reactants, acid or base, and the conjugates on the product side over here are labeled as conjugate acid or base. Okay, that's it. Thank you. Remember, write down any questions you have.